이게 뭐야? 돈이 부족해.
Neon.
Hello.
You know that chemistry lab is due tomorrow.
Oh,
Are you gonna be ready?
Yeah, I have 5 of the 6 ions done.
Just like last time?
Just like last time.
Yeah,
just
late
like
nighter?
last time. No, it's already done. Yeah.
How about you be ready? Hey, this came for you too.
Oh, thank you. Thank you.
Careful.
Yeah.
Hey, you know, be done. On
Yeah,
time.
of course. Always. Always. Hello?
They're coming for you, Neon.
Who's coming for me?
Look up and see for yourself.
What they're coming for? What do I do? What do I get?
You can roost them to the 3rd floor. It's under construction. Listen up. In about a minute, I need you to check your pockets. In them, you're going to find a red pill and a blue pill. The red pill will allow you to wake up from the dream you've been living in, and the blue pill will let you keep sleeping.
Darkness, my old friend.
Sure you want to do that, Neon?
Hello, Neon.
Who are you?
I am more PH.
More PH. Are you the one that was on the phone? Are you the one who contacted me?
Yes, we had to bring you out.
Out of where?
Out of the dream you've been living in, Neon. You've been living in the K-TRIX, Neon. An artificial reality construct designed to keep humans subservient while the machines harvest their bodies for energy.
I don't understand. How does that work?
Well, it's actually quite simple. The machines just... Tank, come in here. Explain, please. I'll leave you two to your discussion.
Hello.
Hey there.
Where exactly are we?
We're on the K-TRIX. It's a ship that allows us to travel through the world undetected by the robots. It's fantastic.
It really is fantastic, isn't it? It's brilliant.
matrix is an artificial reality system which is controlled by various equilibrium.
So, how exactly does that work? I could use an example if you would give me.
Oh yeah, sure, here.
Every object in the K-TRIX has a corresponding molecule in the real world. Lotion, for example, is controlled by silver sulfide. When solid silver sulfide is introduced into a solution, some of the molecules decompose into two silver ions and a sulfur ion. When the machines first created the K-TRIX, there were no silver or sulfur ions present. When they added a certain amount of the solid to the main solution, some of it dissolved, while the rest was left as a solid. Whatever is left as a solid becomes an object in the K-TRIX. As the solution was reaching equilibrium, two silver ions and one sulfur ion would come out of every silver sulfide molecule that decomposed. Current readings show that the concentrations of silver and sulfur in the K-TRIX solution are 4.93 times 10 to the negative 17th molar and 2.47 times 10 to the negative 17th molar respectively. From this information, we are able to find a valuable piece of intel, the solubility product constant. This value, denoted by KSP, is a way to represent how much a particular molecule will dissolve in solution. Because it is equal to the concentration of products over reactants, the KSP for silver sulfide is the concentration of silver squared times the concentration of sulfur. Using the concentrations at equilibrium, we are able to find that the KSP for silver sulfide is 6.00 times 10 to the negative 50th.
Okay, that makes sense. I think I understand.
Yeah, so everything in the matrix has a corresponding molecule in the real world.
Wait a minute. Does that mean that you could change the matrix by changing equilibriums in the real world?
With your grades, not so much. But me, I was top of my class in AP Chem. I could do it in my sleep.
Morbius, you're back.
Neon, we need you to go to the simulation room.
Where
Tank, go to the control room. We need to train you.
Hey, where's the simulation room? Thank you.
Tank, do you have any moisturizer?
Oh, I do.
You're a lifesaver, Tank.
I'm loading the Dojo program right now. Hopefully you can give more PH a run for his money.
Because people are more complex than objects, in order to get them into the K-TRIX, we must form a complex ion in the solution. For neon, I have chosen the tetramine copper ion. This molecule is formed by a single copper ion and 4 ammonia molecules. Complex ions have K values called formation constants. These constants involve a fraction since both the products and reactants have concentrations. The dissociation constant is the K value for the reverse equation and is simply the reciprocal of the formation constant. The solution for the Dojo already contains 0.015 molar copper nitrate. If I make the ammonia concentration 0.1 molar, then I have to make sure that I have enough of the complex ion to get neon into the Dojo. A concentration of 0.01 molar or greater will be enough. First, I must do some stoichiometry to determine the maximum amount of tetramine copper which can be formed. With 0.015 moles of copper and 0.1 mole of ammonia, copper is a limiting reactant. All of the copper will be used to form 0.015 moles of tetramine copper, which leaves 0.04 moles of ammonia in the solution. These values will be the initial concentration used in the equilibrium chart. The reaction will proceed forward and tetramine copper will decompose into copper and 4 ammonia molecules. Whenever we use the equilibrium values in the KF equation, we can cancel the x's, which are subtracted from 0.015 and 0.04, since we assume that they will be significantly smaller in magnitude. In solving for x, we find that it is equal to 1.2 times 10 to the negative 9th molarity. We can then use this value to find the amount of tetramine copper left in the solution at equilibrium. Because this is such a small value, it has little effect on the initial 0.015 molarity, and the final concentration is enough to get neon into the Dojo.
We must train you how to fight, Neon.
Why do you need to train me how to fight?
Remember those people chasing you, Neon? Those were the reducing agents. Programs created within the Matrix to keep us from accomplishing our goals. You'll need to be able to fight them if we're going to complete our mission.
Wow, chemistry's cool.
I need a staff.
Right away, sir.
A staff in the K-TRIX is controlled by silver chloride. Silver ions are already present in the solution, but there are no chlorine ions. If we increase the concentration of chlorine ions by adding sodium chloride, we can cause solid silver chloride to precipitate out. If we add too much, however, lead 2 chloride will also precipitate out and a staph infection will appear in the dojo. Silver and lead both currently have concentrations of 0.1 molar in the solution. First, we must use the KSP value of silver chloride to find the minimum molarity of chlorine ions, which is necessary to cause precipitation of the staph. Plugging in 0.1 for the concentration of silver, we find that a chlorine molarity of 1.8 times 10 to the negative 9th or greater will cause precipitation. Now we must do the same for lead. The same calculation reveals that a molarity of 0.013 or greater will cause precipitation of the staph infection. This means that in order to precipitate the staph without the staph infection requires a concentration of chlorine ions between 1.8 times 10 to the negative 9th and 0.013.
Hey, Jack, give me a weapon.
May I recommend a staff?
No, I want a sword.
A sword in the K-TRIX is controlled by silver acetate. If we add enough of this solid, then eventually the KSP will be reached and no more will dissolve. In finding out how much we must add, we must take into account the silver ions which are already present from the precipitation of the staph. When the silver acetate is introduced into the solution, it will decompose into silver ions and acetate ions. Now, rather than having both initial concentrations at 0, the initial silver ion concentration is 1.34 times 10 to the negative 5th molarity. When the reaction reaches equilibrium, the concentration of silver ions will be equal to 1.34 times 10 to the negative 5th plus x, while the concentration of acetate ions is equal to x. Substituting these values into the KSP expression, we get a quadratic formula. Solving for x, we find that we must dissolve 0.045 moles of silver acetate for every liter of solution. This will get us to equilibrium, and any further additions will stay as a solid and will appear in the dojo.
Take a sword.
I give your skills a 10, Neon. On the pH scale, because they're basic.
Finish him.